Semester review number 35, decide whether Rolle's theorem can be applied to this function on the interval from -1 to 3. If Rolle's theorem can be applied, find all the values of c in the interval. If Rolle's theorem cannot be applied, state why, or state why. So Rolle's theorem is like the mean value theorem. So Rolle's theorem is on the interval continuous. It has to be differentiable. So that's enough for the mean value theorem. If it's continuous and differentiable, then the mean value theorem does apply. Rolle's theorem has a third criteria, that f of a has to equal f of b. In other words, the function has to start at the same start and end at the same y value. So if my function started here, did a whole bunch of stuff, and ended right there, we could use Rolle's theorem because it's continuous, it's differentiable, it's smooth and not vertical, and it starts and ends at the same y value. So that would be an example of when Rolle's theorem does apply. If this is a different y value than that, the mean value theorem still applies, but Rolle's theorem doesn't apply. So Rolle's theorem states that if we start and end at a y value and it's continuous and differentiable, there has to be a point somewhere in the interval where the derivative is 0, which makes sense because the mean value theorem states that too. What is the average rate of change from here to here? Well, if it's horizontal, the average rate would be 0. Okay, so there has to be a point or points on the interval where the instantaneous rate of change is 0. And that sounds, I mean, that's what the mean value theorem is. Rolle's is just a special case of the mean value theorem. Okay, so let's figure out if Rolle's theorem apply. Well, this is a polynomial. Polynomials are always going to be smooth, they're going to be continuous, differentiable. So really the only issue is, does -1 and 3, do they produce the same y value? And that will determine whether Rolle's theorem applies. So -1 gives you 1 plus 5, and so 5, 9, 10. So -1 comma 10 with my mental math. 3 is 81, oh boy, minus 4 times 27, better grab the calculator. So 3 to the 4th minus 4 times 27 plus 36 plus 1 gives you 10 also, so 3 comma 10. So they both have the same y value, so Rolle's theorem does apply. So we need to continue on the problem. We need to figure out where in the interval okay, so we find the derivative. And then we set it equal to 0. Luckily, they all have an x. So I'm going to set it equal to 0 and factor out an x. 4x squared minus 12x plus 8. Heck, we could have taken out a 4, and that would have been better. So 4x times x squared minus 3x plus 2. Even better, it's factorable, looks like. So x minus 2, x minus 1. So we have 3 times in which it occurs, at 0, 2, and 1. So 0 values in which Rolle's theorem applies in that interval.